Welcome to the pre-calculus, everyone. We studied function and graph last lecture. Today's we're gonna discuss transformation of graph. After this lecture, you will be able to identify parent function, then you know key feature of each function. Second, you're gonna apply basic transformation such as shift, refraction, stretch, and shrink. After you start transformation, you can sketch the graph of transformed function. Then you also write the equation of transformed function. Let's get started today's lecture. Before we start transformation, let's explore basic function. We're gonna call them parent function. First, fx equal x. What's the name of this function? Linear function. So how gonna sketch linear function? You have created table. You pick the 3 and 4x value. Plug in the x in the function, evaluate. We learned how to evaluate, right? So you pick the 3 or 4x value, -2, 0, and 2. You plug in the x to evaluate f of x equal x. That's gonna be -2, 0, and 2. After you making table, you're gonna sketch the graph on the coordinate plane. -2 and -2, 0 and 0, 2 and 2. You plot the point, connect the dot. That's how to sketch linear function. After sketch the function, you can find the domain, Euler number. You also find the range, Euler number. Domain gonna be Euler number. Interval notation, -infinity, +infinity. Range gonna be also Euler number. -infinity, +infinity. That's how to sketch function. Let's have another function. f of x equal absolute value of x. What's the name of this function? That's gonna be absolute value function because they have absolute value. So before we sketch the absolute value function, we're gonna make a table like that. I picked only 3x value, -2, 0, and 2. Find the y value. Absolute value -2 gonna be 2. Absolute value of 0 and 0, 2 and 2. So we're gonna sketch coordinate plane. So plot the -2 and 2, 0 and 0, 2 and 2. So you plot it, you connect the dot, then you have V-shape function. So we call this is absolute value function. What is domain? Look at this graph very carefully. So you see graph is above the x-axis, which meaning is no negative y value. But domain gonna be Euler number. Range gonna be what? You have very careful. Because no y value below the x-axis, which meaning is all y value gonna be positive and 0. So range gonna be 0 and infinity. Okay? Let's have 2 more parent function. Next one is f of x equal x squared. What's the name of this function? Quadratic function. Make a table we did previous slides. See, I picked the 3x value. -2 square is 4. 0 square is 0. 2 square is 4. That's you find y value and sketch this function on the coordinate plane. You're gonna plot the point, then connect the dot. But very careful. Quadratic function is a curve, not a straight line. You sketch the graph smoothly. What is domain? Domain is Euler number. like absolute value function, range gonna be no graph under the x-axis, which meaning is all y value gonna be positive or equal to 0. So range gonna be 0 and infinity. Okay? Next one is square root function or radical function. Make a table 0, 1, 4. Why I picked all the parts? Because you can plug in negative inside the square root. So I picked all the positive number. Square root of 0 is 0, 1 is 1, 4 and 2. So you have this. Order the pair, then sketch it 0, 0, 1, 1, 4, 2. Plot the point and connect it. But very careful, this is also curve. Very carefully, take a close look at this graph. Graph only first quadrant. So which meaning is domain gonna be positive or 0. Range gonna be positive or 0. So domain is 0 and infinity. Range also gonna be 0 and infinity. Now, let's just start transformation. So we know all the parent function. Now, first one is vertical translation. Vertical, you're gonna move function up and down. That's what we call vertical translation. So how gonna change the form of function is f of x is a parent function. You're gonna add k value. Depends on k value, you're gonna move the function up and down. So k is positive, you're gonna move function up. K is negative, you move the function down. So k gonna be positive, shift up. K is negative, shift down. You have to remember that. So let's have first example. Y equals x squared. That's the quadratic function. I sketched the quadratic function right there. So first example is y equals x squared plus 2. K value is positive. You're gonna move up. How much? 2 units. Shift up 2 units. You're gonna move up this graph 2 units. So 0, 0 move up to 2. 1 and 1 move up to 1, 3. Negative 1 and 1 move up to negative 1 and 3. Another way, you slide up the graph. How? Like this one. Slide up. So that's how to translate vertically. K value is positive. Another example is y equals x squared minus 4. K value is negative 4, which meaning is shift down 4 units. So you have function, original function is right there, guys. That's move down y equals x squared minus 4. You're gonna move down 4. So that's gonna slide down 4. That's how gonna transform the vertical translation. Let's have first example. So y equals absolute value of x minus 3. First you have find the parent function. That's gonna be y equals absolute value of x. Then sketch the parent function. Y equals absolute value of x. Now let's figure it out. Vertical translation, that's outside absolute value of x. That's meaning is negative 3 right here. That's gonna be moved down because k value is negative. So slide down 3 units. Okay? Shift down 3 units. Slide down this function 3 units. So 0 going to negative 3 here. Slide down. 1 go to negative 2. Here is 1 go to negative 2. So slide down 3 units. That's how sketch the y equal absolute value of x minus 3. Let's have another example. Y equals square root x plus 2. I said you have figured it out parent function. That's gonna be square root x right here. So what kind of shift they did? Go up 2 units. So I sketch the square root function, move up the 2 because add 2, shift up 2 units. So 0 move up the 2, 1 move up the 3. Here is a 2 move up the 4. So guys, here is pay attention what I'm saying here. You're gonna move the y value, not x value. Slide up the graph, but which meaning is you're gonna change the y value. So slide up 2 units right there. So 0 go to 2, 1 go to 3. Here is 2 go to, oh no, sorry, here 2 go to 4. Okay. Previous slide we study vertical translation. Now we're gonna study horizontal translation. Vertical translation meaning is you're gonna shift the graph up and down. Horizontal translation meaning is you're gonna move graph left and right. Here is very careful, guys. Look at this x minus h. Inside, x will be replaced x minus h. That's the first thing you notice. Here is negative sign. So h is gonna be two value, positive and negative. H is negative, meaning is inside the parenthesis is gonna be positive. You have very careful with that. H is positive, shift right. H is negative, shift left. What do you mean by that? I give the example. F of x is x squared. You're gonna sketch the fx equal x squared quadratic function. So first example is y equal x minus 3. Here is x gonna be replaced x minus 3. Another thing is here is negative. H gonna be this time is 3. That's gonna be positive. So you're gonna shift to the right, guys. Shift to right 3 units. Slide right, okay? So this one is slide right. 0 go to 3. Here is 1 go to 4. Here is 1 go to negative 4. What I mean by that, guys, 0 is x value go to 3. Here is 1 go to the 4. This x value change. Here is negative 1. Negative 1 and 1 go to this point. Slide right. Slide right the 3. Guys, very carefully say x value change this time. Another example here, guys. So y equal x plus. So no, you have see here negative. Here is positive. Meaning is negative is stay here. Inside is negative, which meaning is h value is negative. So shift to left. How much? 3 units. Now, original function is right here. You're gonna shift the left 3 units. Move to the left everything, which meaning is change the x value. 0 go to negative 3. Here is, I say 1 go to the negative 2. Here is negative 1 and 1 go to negative 4 and 1. So vertical shift change the y value, horizontal shift change the x value. Very careful with the sign, guys. H gonna be positive right, H gonna be negative, gonna be left. Let's have first example about the horizontal translation. Here is g of x equal absolute value of x plus 2. Inside the x value gonna be changed, okay? So find the parent function. That's gonna be absolute value function. You're gonna sketch it, absolute value function right here. Now, what do you have to do? You have to check it out here. Inside the absolute value change, which meaning is that's the horizontal translation. Here is a positive meaning is negative, negative 2. So h gonna be negative 2, right? So you're gonna translate left or right, guys? Left. How much? 2. Slide to the left, 2, guys. This point going to here. This point going to here. This point going to here. So slide to the left 2 units. So slide it. That's how to sketch g of x equal x plus 2. You're going to have another example. H of x square root x minus 2 inside the square root change. So parent function gonna be square root x. Let's sketch the square root x graph right there. Now check it out inside the square root. X minus h gonna be 2. Shift to the right 2 units. Shift to right 2 units, right? So you're gonna move everything to the right 2 units. 0 going to 2. Here is 1 and 1 going to 3 and 1. 4 and 2 going to 6 and 2. So slide to the right 2 unit. That's how to sketch horizontal translation. Let's combine two translation, vertical, horizontal. Can you see, guys? Look at this. Y equal absolute value, x plus 1, they change outside absolute value changes. So you have two translation. First, you find the parent function. Parent function gonna be absolute value of x. How many translation they had? First one is inside, second is outside. Inside is x plus 1. That's gonna be shift to left because here is a positive. Outside, that's gonna shift to left, positive. Outside gonna be 2. That's gonna be move up 2 unit, right? You're gonna move up 2 unit. That's how to sketch it. Guys, it makes sense? Have another one. H of x equals square root x minus 3 minus 2. What is parent function? Y equals square root x. Let's just sketch parent function right here. How many translation you did? Inside the square root, outside the square root. First one is, can you see the 3? X minus h. That's meaning is shift to the right 3 unit. Shift to the right 3 units. Outside, negative 2 meaning is move down. How many? 2 units. You're gonna move down 2 units. So make sure inside the square root, that's the vertical translation. Oh no, I'm sorry, horizontal translation. Outside gonna be vertical. Now we're gonna do vertical stretch and shrink, guys. The vertical meaning is always they're gonna change y value. So here is a form of vertical stretch and shrink. Y equal f of x, that's the y value, times it. When you times it, that's we're gonna say stretch and shrink. A value is greater than 1, you stretch it. A value is between 0 and 1 is you shrink it. So very carefully see, in front of f of x, you multiply by a value, that's we're gonna vertical stretch and shrink. Let's have first example. F of x is absolute value of x. You're gonna sketch it, absolute value of x, that's V shape. First example is y equal to absolute value of x, which meaning is 2 gonna be times to the absolute value of x. So we say that's gonna be vertical stretch y, okay? So y value change, how gonna change? You times it. So here is absolute value function. Now 1 and 1 here, y value is 1 times 2, that's going to 2. Negative 1 and 1 this point, y value is 1 times to go up. So you're gonna plot that point 1 and 2, negative 1 and 2, you connected that, so you have V shape, but this V shape close the y-axis. So when you stretch vertically, then you're gonna have graph getting close to y-axis. Another example is 1.5 absolute value of x. That's the a value is 1.5. Vertically shrink by 1.5, which meaning is 1 and 1. Y value is 1 times 1.5. That's the 1/2. Negative 1 and 1 times 1.5. That's the 1.5. So y value shrink by 1.5. So you're gonna connect to this dot. You see the green graph. That's the y get far away from the y-axis. That's vertical shrink. Now let's study refraction over x-axis. So see it here, guys. So original function is y equal f of x. Only change the sign. Focus on the sign, guys. Sign y equal negative f of x. That's gonna be refraction over x-axis. Okay. So here is an example. F of x equal x squared. You're gonna have this graph. We wanna sketch g of x gonna be negative x squared. So here is in front x squared. Here is 1 positive. Here is a negative 1. Here is negative 1. How gonna sketch y equal negative x squared? So you see point. Here is 2 and 4. Y value is 4. Change the sign of y. 2 and negative 4. 2 and negative 4 is right there. 0 and 0 is 0 and 0. Negative 2 and 4. Change the sign of y value. Negative 2 and negative 4. Here is right there. You're going to plot the 3 point. Here is right there. So negative 2, negative 4, 0 and 0, 2 and 4. That's you're going to sketch y equal negative x squared. Okay? So flip over the x-axis when you see negative sign outside of f of x. We did the refraction of x-axis, which meaning it changed the sign of y. This time, refracts over y-axis. Can you see that here is x gonna be changed? Sign of x gonna be changed. So very careful. Refraction over x-axis, you're gonna put the negative outside f of x. Refraction over y-axis, you're gonna change the sign inside the parentheses. So here is an example. F of x is square root to x. I want to sketch this function. F of x is square root to x. So we want to reflect this function over the y-axis. See that? X, change the sign, negative x. So you see negative x inside the square root. That's gonna be reflects over y-axis. When you reflect over y-axis, you're gonna change of sign of x value. 0 and 0 and 0 and 0, 1 and 1. Change the sign of x value, negative 1 and 1, 4 and 2. Change the sign of x value, negative 4 and 2. That's you plot it right there. So 1 and 1, negative 1 and 1. Here is negative 4, 4 and 2, negative 4 and 2. Okay? Then you plot the graph, connect the point. You're going to find y equals square root to negative x. Here is one more example of refraction over x-axis, y-axis. Guys, see that? Y equal f negative x, y equal negative f of x. Here is change the outside sign. Here is change the inside sign. When you change the sign inside the parentheses, x gonna be negative x. That's gonna be reflect over y-axis. Outside the sign gonna be changed. You put the negative outside the f of x. That's gonna be reflects over x-axis. How gonna do that? You're gonna point by point. Negative 1 and here is point negative 1 and y value is negative 1. 0 and negative 1. Stay there. Here is right there. Y-axis. This one stay there. How about this point? 2 and 2. Refract over y-axis, that's meaning sign of x change. 2 and 2. Here is gonna be negative 2 and 2. 3 and 2 gonna be negative 3 and 2. 4 and 0 gonna be negative 4 and 0. You connected a point. Then you're gonna have the graph refract over the y-axis. Okay? Here is another example. This time you're gonna refract over x-axis. You're gonna change the sign of y. So here is start with 0 and negative 1. Change the sign of y. 0 and 1. Here is 2 and 2. Meaning is 2 and negative 2. 3 and 2. Here is 3 and negative 2. 4 and 0. Still 4 and 0. So you're gonna connect to this point. You have graph of f y equal negative f of x after refraction over x-axis. Let's just summarize transformation we studied. This is order you consider when you transform the function. First one is horizontal translation, which meaning is shift left and right. Second is vertical stretching or shrink. Third is refraction over x-axis or y-axis. Last one is vertical translation. Please keep in mind, you should keep this order to figure it out, the old translation. Let's have first example. They give function of this form. Oh, it looks complicated. But we're gonna start with the parent function. What is the parent function here? Y equal x squared. That's the parent function. I sketched the quadratic function right there. First transformation, you're thinking about horizontal. Horizontal meaning is inside x. So let's go to horizontal translation. X minus 2. So that's gonna be shift the right 2 unit, shift to the right 2 unit, shift to right 2 unit. So we have y equal x minus 2 squared. You're gonna shift this graph to the right. You have moved 2 units, okay? Shift to the right 2 units. That's the first. You have figured it out. What is the second transformation we consider? That's the vertical stretching and shrink, right? When you do the vertical stretch and shrink, don't consider sign, only number. What is number there? 1.5. 1.5 is less than 1. That's meaning it's a vertical shrink. So, okay. Vertical shrink the y value, okay? So here is, you have 2 and 0. Y value 0 is, shrink is still 0. Another one is gonna be, here is 0 and 4. Y value is 4. Shrink by 1.5. That's gonna be 0 and 2. Another one is 4 and 4. Y value is 4. Shrink by 1.5. That's gonna be 4 and 2. You're gonna sketch the graph like that. Shrink meaning is far from the y-axis. So you have 1.5 x minus 2 square. Very careful, don't consider sign. Sign is related to the refraction. Now we finish up 2 translation. Now we do the next one. Next one is refraction. Sign gonna be outside x minus 2 square. You're gonna put the negative outside. That's you should know this is refracts over x-axis, refracts over y-axis. What is gonna be, guys? That's the refracts over x-axis. Outside, you put the negative. So how gonna sketch refracts of x-axis? Gonna be flip this graph over the x-axis. You're gonna change the sign of y value. 0 and 2, 0 and negative 2, 2 and 0 doesn't change. 4 and 2, y value change, 4 and negative 2, right, guys? So you're gonna have this graph flip over the x-axis. You have form of y equal negative 1.5 x minus 2 squared. We finish up the 3 translation. You have one more. That's the 3. That's the vertical translation. That's the positive 3. You're gonna move up 3. So this graph move up 3. You're gonna change the y value. Add 3 every point here. So you're gonna slide move up 3, guys. Then you have equation y equal negative 1.5 x minus 2 square plus 3. So look at this. We have 4 transformation. Keep to this order. Horizontal translation, vertical stretch and shrink, reflection of x-axis or y-axis, vertical translation. This example, we write the function after all the transformation. First, we're going to start parent function y equal x squared. So I'm going to give transformation. You write the function after transformation first. Shift 2 units to the right. 2 units to the right, which meaning is you have changed inside x, which meaning go to the right x minus 2, right? So y equal x minus 2 squared. What's next translation gonna be? Stretch vertically by 2. You're gonna times it vertically, stretch in front of x minus 2 squared. So y equal 2x minus 2 squared. Next one is refraction. Cross the x-axis. Refracts over x-axis, which meaning is change the sign of a whole thing right here, not the inside. So y equal negative 2x minus 2 squared. Last one, shift up 3 units. So you're gonna add plus 3. Y equal negative 2x minus 2 squared plus 3. That's you're gonna find the function after transformation. Now, we have function. You're gonna identify the transformation. So first step, you have find the parent function. As you see, this is gonna be, guys, this is gonna be radical square root. So parent function gonna be y equals square root to x. Look at this one, y equals square root to x, they have negative 3 plus 2 negative, which meaning is you have to find the 3 transformation. First one is you follow the step. Horizontal translation, they did? Yes, they did. Inside the square root to change x minus 3, very careful the sign. You have 3 right there. Shift to the right 3 unit. Shift 3 units to the right. That's you see the number right there. That's you done. Second is stretching and shrink. Can you see the number in front of square root? No, you only see the sign. So there is no shrink and stretch vertically. Third one is refraction cross the x and y axis. They change the x sign? No. They change outside the square root. That's gonna be refract over x-axis. Guys, make sense? You have one more to go. That's the vertical translation. You have 2 is outside of square root function. So which meaning is k value is positive. Let's move 2 units upward. That's you figured it out. Or the transformation from the parent function. What do you learn from this lecture, everyone? So first we learn transformation change the position or shape of graph, but they keep the same basic parent function. Okay. Second is horizontal translate, change the x value, guys. Keep in mind. Vertical translation gonna be changed the y value. Third one is refraction is flip the graph across the x-axis, y-axis. Then everything begin with the parent function. Apply the transformation by the order. Horizontal translation, stretch and shrink, and reflection, then vertical translation.